here is one of the test tubes that we're testing for pH. Okay, this has a pH buffer of 2, a pH of 2, and 1 milliliter of catechol. So we used 1 milliliter of the pH 2 buffer and 1 milliliter of catechol. So we did it for pH of 4, and we did the same measurements for each. pH of 6, pH of 7, a neutral pH, and if I may mention, pH of 6, 4, and 2 are acids. They are below 7. They have more hydrogen ion concentrate. This is pH of 8, above 7. It is a basic solution. pH of 10. pH of 12. And what we're going to do is we're going to incubate these at 37 degrees Celsius along with the catechol oxidase enzyme to see if we can garner a reaction and see which of these pHs has the best result. Here, we are showing the results of our pH experiment. Here we have a pH of 2 buffer, okay, where we added the 1 milliliter of pH 2 buffer, 1 milliliter of catechol, and 1 milliliter of catechol oxidase enzyme. And we incubated this at 37 degrees Celsius. As you can see, there's some reactions, very slight, but still some benzoquinone produced. So, Professor Phillip explaining pH number 4.
Now, we added 1 ml of catechol and 1 ml of pH 4 buffer in this test tube. Then we added the catechol oxidase and put it at a temperature of 37 degrees Celsius. Now, you can see some precipitate in the middle, and
sorry about the condensation.
It has a brownish color, but it's a bit light, so there was some
reaction.
Some of it.
Okay. And this is a pH of 6. This is our positive test result. You can see this is a little lighter, but you know, even though it's slightly acidic, it still had some reaction, a pretty decent amount. So you can see that it did react pretty well, and there was benzoquinone produced.
And since apples are a bit acidic, right?
Awesome.
Apple juice, right?
Yeah.
So when they turn brown because of the chemical reaction with the oxygen and the catechol, we can assume that if it's a little bit acidic, then it would cause a reaction.
Here's pH of 7, a neutral pH, no acidity, compared to the positive control. Now, as we compare it to pH of 6, and the positive test result, pH of 6, 7, test result, positive control.
Are we in the middle?
Okay. Positive control, pH 6, pH 7. pH 6 is actually a bit darker than pH of 7. Okay, pH 6, pH 7. So we can see that at slightly acidic pH, we get more of a reaction. Here's our test for pH of 8, which is even lighter than pH of 7. And then our pH of 10 is a bit less, is a lighter shade than pH of 8. pH of 12, like pH of 8, less reaction. In fact, this has the really basic pH reacted less than the really high acidic pH, a pH of 2, 12. You know, this has more darker shade. So from this, we deduce that the optimal pH for catechol oxidase
would be slightly acidic.
At our pH of 6. Okay? Action. Here we go. Welcome to Emon and Phillips
Biolab World.
Extreme. Woo! Alright, so back to the science. Extreme science. This we've been incubating for a while. There's still some condensation.
It's
There's a lot of
been
water
what?
and stuff.
An hour, maybe? An hour, probably?
A while.
Yeah.
Yeah. We were doing it at 37 degrees Celsius. As you can see, it's still no reaction. So what we're gonna do is we're gonna boil it and see if this, which has no enzyme, will react at the level of at a high temperature of water, a high temperature. See, because as we explained before, an enzyme lowers the activation of energy. So what we're gonna try and do is get it up to that level where it starts the reaction, and we're gonna boil some water and put that in there. Okay. So here is the solution that we had that we were boiling without any enzyme in it, and it's really hard to see, but there is a slight change, and after maybe half an hour of boiling, like actual 100 degrees Celsius boiling, only very slight reaction. So it just gives you an idea of how much energy is really required and how much an enzyme does to make a reaction like this. Like, you wouldn't live without enzymes.
So this shows you that enzymes are essential for life
Extremely, bro.
and in the human body.